All right, we're going to be talking about 2-3. This is a long section. We've done long division, we've done synthetic division. Now we need to add two more things to our toolbox for our factoring completely, and that's going to be P over Q and Descartes' rule of signs. The remainder theorem says, what we just learned was from synthetic division, that F at K is equal to R when you do synthetic division. That's super, super important, so that we already learned this. The factor theorem says that if x minus k is a factor if the remainder is equal to 0. We already knew this as well. Now, what we don't know is going to be called the rational zeros test, which is P over Q values. Given a polynomial f of x, with all coefficients being integers, meaning the numbers in front of the variables, P divided by Q is all the possible rational zeros. Now, first of all, I need your brain to think of rational. What does rational mean? Rational means fractional or whole number. Zeros of f of x, where P are all the factors of the constant and Q are all the factors of the leading coefficient. What do I mean? Well, you need to understand the real number system. The real number system has rational numbers and irrational numbers. Whenever I'm talking about irrational numbers, I'm talking about the square root of 3, the square root of 2, pi. Those are all irrational numbers. They're messy numbers that we don't typically use in real life math, okay? Rational numbers, all of this over here, are all the numbers that we use all the time. These are the numbers that make us super happy. So we have 1, 2, 3, we have -5, -10, -11. We have 1/2, -3/5, 7/9. Those are all examples of rational numbers. Our whole numbers, our integers, and then our rational numbers. These are the numbers that our brain understands. We like these ones. They make us happy, okay? What we don't like are going to be our irrational numbers, because those are the numbers that just make our brain explode sometimes. So what our P over Q values do is they give us our list of all the possible rational numbers that could be solutions to our problem. Okay, that's what the rational numbers do. That's what the P over Q list does. The next thing that we need to talk about is we want to take that rational list of P over Q values, which could be really long, and we want to then cut it down even further and make it minimal so that we have less numbers to check for roots. Well, Descartes' rule of sign helps us do this. This is used to find the number of positive and negative roots a polynomial has. So for example, if I have a degree 4, I would want to know if I'm going to have 2 positive roots, 2 negative roots, 3 positive roots, 1 negative root, 4 positive roots, 4 negative roots. I would want to know all the scenarios that I could potentially have, okay? Well, how can I determine that? I determine that by counting the sign changes. For my positive, I count the sign changes in the original polynomial. And then I'm going to subtract 2 until I get down to the number 0 or below. And that's going to be what I have. Example, if my number of sign changes was, let's say, 4, then I could have 4. 4 minus 2 is 2. 2 minus 2 is 0. I can't go below 0. If n was going to be, let's say, 3, then I would have 3 minus 2 is going to be 1. 1 minus 2 puts me at -1. So I'd have to have 3 or 1, which means I'd have to have a positive root. That's for positive sign changes. Now, negative sign changes, you are going to count the number of sign changes in f at -x. Super important. You're replacing x with a negative x. And then you're going to do the same process and subtract. This includes imaginary roots. So important for your brain to understand. What do I mean? I'll get there in a second. Now, the discriminant, x equals -b plus or minus the square root b squared minus 4ac all over 2a. That is the quadratic formula. The quadratic formula is something you learned back in Algebra 2. The discriminant is this handy-dandy little value directly underneath the square root symbol, which is the b squared minus 4ac. The b squared minus 4ac tells us an awful lot about the type of parabola we are going to have and the type of solutions we will have. If that number is bigger than 0, then I have a perfect square, that means I'm going to have rational roots. That means I can visibly see them, they're going to be beautiful, or they're going to be two real roots that I can see. If it is less than 0, I can't take the square root of a negative number because that puts me in the imaginary number system. If it's less than 0, then that means my roots are imaginary. And if it's equal to 0, then that means I have a double root. Remember what a double root is? Multiplicity 2. It touches the x-axis, doesn't go through it, does not go through it, and goes right back up. So this deals with multiplicity, which is super important for your brain to understand. Now, we are going to do all of this right now, and we're going to apply everything that I just talked about. So the very first thing that I want to apply is going to be the rational roots theorem. Rational zero test is whenever we're taking our p-values over our q-values. Our p is our constant, and our q is going to be our leading coefficient. So let's come over here and say, here's our problem. So if this is our problem, I have 2x cubed plus 3 minus 8x plus 3. Now, remember p. P is going to be all the factors of my constant term. My constant term is 3. So what are all the factors of 3? I have to do plus or minus because I can have a positive or a negative. Plus or minus 1 and 3. Now, Q are going to be all the factors of my leading coefficient term. So if that's going to be all the factors of my leading coefficient term, that's going to be a 2. Okay? All the factors of 2 are going to be plus or minus 1 and plus or minus 2. And yes, I have to include plus or minus. So my entire list is plus or minus. I'm going to take my entire numerator. Why do I do that? I'm going to take my entire numerator and first divide by 1. So 1 divided by 1 is 1, 3 divided by 1 is 3. Now I'm going to take my entire list and I'm going to divide that by 2. So what is 1 divided by 2? 1/2, and 3 divided by 2 is 3/2. You know what this means? That means whenever I graph this function, I'm going to choose the biggest number up there. My biggest number up there is a 3. This will help me find my window size. My window size means I'm going to go 1 unit past it and 1 unit to the left of it. So my window size is going to go from -4 to +4. Meaning I can graph this thing and it's going to cross between -4 and +4. Why? Because the largest rational zero that it can be is +3. And the smallest rational zero that this can be is -3. So if I set my viewing window to be -4 to +4, I will see all the possible roots that it could be for rational right there. Okay? That's super important. Now we're going to take the same thing and then we're going to go ahead and find the rational. We're going to do the Descartes rule of sign. Descartes rule of sign tells me how many positive, negative, and imaginary roots I'm going to have. Now, remember, this thing is degree 3, so I have to have 3 roots. Either 3 positive, 3 negative, 3 imaginary, which is impossible, or a combination of them. Whenever I said it is impossible, it's because imaginary roots come with plus and minus. When you take the square root, you have a plus or minus. So they come in pairs. So with that being said, I'm going to go ahead and I'm going to count the number of sign changes in my positive, can't spell, positive sign changes. So I'm going to go in my original. +2 to +3. Did my sign change? No. How about +3 to -8? Yes, there's 1. How about -8 to +3? There's 2. So my number of sign changes is 2. So that means I can have 2 positive, 2 minus 2. So 2 minus 2 is going to be 0. So I have to have 2 or 0 positive roots. Those are my options. 2 positive roots or 0 positive roots. Okay? Now, negative sign changes. Now that means I have to do f at negative x. Well, that means the ones that are going to change are just the odd exponent ones. So that's going to make that 2x cubed. I keep the 3x squared because it's squared. Negative 8x changes to positive 8x, and I keep my constant. I repeat, when I am putting in a negative x in place of positive x, the only coefficients that change are odd-powered coefficients. 2x cubed now becomes negative 2x cubed. 3x squared is even, so it stays as 3x squared. Negative 8x to the first is odd, so that becomes positive 8x to the first. And then 3 is x to the 0, so 0 is neither positive or negative, so you leave it alone. So, how many sign changes do I have here? A negative 2 to a positive 3, there's 1. A positive to a net positive, nope. Positive to a positive, no. So n is equal to 1. Now I need to do n minus 2. Well, 1 minus 2 puts me at negative 1, so I can't do anything with that, so I'm done. Which means I have to have one negative root no matter what. My total is 3. So how many are left to be imaginary if I have 2 positive and 1 negative? 0 are left because I have to have a total of 3. How many are left to be imaginary if 0 are positive and 1 is negative? That leaves 2 to be imaginary. Let's do this all again. Same exact procedure all over again. So here we go. New problem. I want to do P divided by Q. P comes from my constant. So that's going to be 4. Factors of 4 are plus or minus 1, 2, and 4. 1 times 4, 2 times 2. Okay? My leading coefficient is 3, and that is going to be my Q. All my factors of 3 are 1 and 3. So my P over Q list, is going to be, I'm going to take them all and divide them by 1. So that gives me 1, 2, and 4. Now I'm going to take them all and divide them by 3. So that's going to give me 1/3, 2/3, and 4/3. I do not have to repeat them if they come up again. I do have to reduce them. So if I have 8 divided by 4, that is 2. I don't have to write 8 divided by 4 because I already have 2 in my list. Okay? This is all your possible rational roots. Now my window size. I'm going to find my largest number up there. My largest number is 4. And I'm going to go 1 unit to the right of that and 1 unit to the left of that. So -5 and +5. What do I mean? When I graph this function, if I am between -5 to +5, I will see all the possible positive roots or rational roots in there. Okay? So that means you are done with that. Now, let's do Descartes' rule of signs. Descartes' rule of signs is found by counting the number of sign changes. So with that being said, I want positive. So positive roots, how many do I have? Well, I'm going to have a +3 to a -5, there's 1. -5 to +6 is 2. +6 to -4 is 3. So I have n equaling 3. So that means I could have 3 positive roots. 3 minus 2 is 1. And then 1 minus 2 gives you -1. That doesn't help me, so I have to have 3 or 1. So we're going to go ahead and do the next one. Now I need to find f at -x. Now remember, which ones did I say would change? Even roots, even powers, or odd powers? Odd powers, coefficients, are going to change their signs. So this is 3x cubed, so that becomes -3x cubed. Negative 5x squared stays as negative 5x squared. 6x to the first changes to negative 6x, and minus 4 drops down. So now let's count the negative sign changes. So negative to a negative, nothing. Negative to a negative, nothing. Negative to a negative, nothing. I have 0. Now let's go ahead and make our chart. I have positive, negative, imaginary, and our total. The total number of roots has to equal my degree, which is 3. So I can have 3 or 1 positive. If I have 3 positive, 0 is how many I'm going to have for negative roots every time, which leaves me 0 imaginary and 2 imaginary here. Okay? Tonight's homework is 2-3 worksheet 2, P over Q, Descartes' rule of signs.